Hello everyone and welcome back to your YouTube channel and welcome to this amazing video today. And I will be showing a very simple, very specific case. It's a numerical example about the inertia constant. We are using the letter J. And this very specific example is to show you that the units are extremely important when you are working with electromechanical systems. And in this very specific exercise, this very specific example, we are covering the inertia constant calculation of a synchronous generator, but in this case we are using very specific units different to the classical MKS system. And before any other delay, let's start here. Let us consider a 60 Hz 4-pole synchronous generator, and the rate apparent power is 85 MVA, with a rate voltage, stator rate voltage of 13.2 kV. And remember, this is line-to-line voltage, RMS voltage, and this machine has an inertia constant, rotational inertia constant H of 6.42 megajoules per MVA. You must remember megajoule per MVA is equivalent to megawatt second per MVA. But now there is the very interesting question here. Determine or calculate the inertia constant J, but using the British units, pound per square feet. Okay, that is what we will do here. Initially, you can put here the data: 60 Hz, 85 MVA, 4-pole, and 6.42 megawatt second per MVA. To be honest, the idea of this example is to demonstrate my students how important the units are and how those units can change from one place to other place in this wide world. The idea is to show you that depending on the country, you can see different units. And if you don't care about the units, or you assume that all the units are the same, well, you can be in huge troubles, okay? Well, let's start with this calculation. The first step here is that we need to know the kinetic energy. And we have, like, I don't know, but we have many videos in the channel talking about kinetic energy calculation. And all my clever and brilliant students, they know that the kinetic energy is connected to the rotational inertia H and the rate apparent power. If you remember the definition, it's very simple for you to remember that the kinetic energy in megajoules is equal to H in megawatt second per MVA multiplied by the rate power in MVA. From there is just a numerical substitution inside the equation: 6.42 megawatts seconds per MVA multiplied by 85 MVA. When we put the number together, voila, we get the magical number over here, and the total kinetic energy stored at the rotor at synchronous speed is 545.7 megajoule or megawatts per second. The next step here, I calculate the synchronous speed. We have here at the top the electrical synchronous speed. Below that, we have the mechanical synchronous speed. And I use the different rotational speed, in this case in electrical radians and mechanical radians per second and RPM, okay? I will not go through this detail, but you can see over here that the electrical synchronous speed is 3,600 RPM. And on the other hand, the mechanical synchronous speed is 1800 RPM. All of this is 188.4 radians per second. Well, in front of you, you have this amazing equation over here. If you look the definition over there, you can see that now they are something different. First thing, I am calculating the inertia constant J. And here we have pounds per square feet. And now what we need to do is substitute these variables here, the rate power in MVA, H in megawatts per second per MVA, and the rotational speed in RPM. This 2.31 and this 10 exponent 10, they are basically coming from converting units. I will not go in those details over there because I am sure this equation is properly done. But if you want to exercise and prepare for exams, I highly suggest that you run the appropriate unit conversion and obtain the equation above. Otherwise, you can see that equation is already available in many books. You can go to Paul Anderson, you can go to Condor, you can go to Kimbark. There are many books where you can find that equation. I highly suggest to my students go to those books and follow the unit conversions and have a look on that, okay? Well, when we put the number together, we obtain this magical inertia constant J. In this case is 729,116.5 pounds per square feet. This is the result. This is the inertia constant J, and this is the end of this video. I hope you enjoy. If you find useful, please subscribe to the YouTube channel. And also, please, if you have any question or any doubt, please go and leave over there any comment or a message, and I will be extremely happy to help you. Well, that's all for today. Thank you very much. Bye now.